So I welcome you to my new video. Today's question is find first and last position of element in sorted array. So given an array of integer nums sorted in non-decreasing order, find the starting and ending position of given target value. If target is not found in the array, return -1, -1. You must write an algorithm with big of log n runtime complexity. So what is the question saying? Suppose this is an array. You have to return the first and the last occurrence of 8. So starting and ending position, starting position of 8 is 3 and ending is 4. Suppose 6 is not existing, so we have to return -1, -1. Empty array also, we have to return -1, -1. So this is the question. I hope you understand the question. Now let's move to the brute force. Although brute force is not asked in the question, but we'll try to understand what the question is. So first of all, brute force will come in your mind that let's start the first, inside the first and last with -1. Okay. Then what will we do? Then we will start a for loop. Int I equals to 0, I less than n, I plus plus. Then what will we do? We'll check if 5 is equal to if nums of I is equal to target or not. Suppose if it is equal and if it is equal to first time we have seen it, first is -1, then we will update the first two I, and last will be updated every time. First time last will be 0, 1, 2, 3, 4, 5. First time last will be 3, and then at this point last will update to 4, but first will change, update only first time when -1. So this is the basic brute force approach, and this will return your answer. Then you can return first and last, first comma last. Okay, this is the brute force, but we should optimize the solution to big of log n. What can we do? I will show you. Wait a minute. Now let's optimize our solution. Let's take a concept. Suppose this. See, 8 is here, and first index is, first occurrence of 8 is here, and last occurrence is here. What are these indexes? See carefully. Can we say it is like a lower bound, because lower bound definition was greater than or equal to target, smallest index which was greater than and equal to target. Can I say this? It is the lower bound. Yes, you can get lower bound equals to 3. Okay. Now can we say 8 is can we say 10 is upper bound of 8, because upper bound definition was greater than target, and 10 is greater than 8. Can we say 10 is upper bound? Yes, you can say. So what will be the last occurrence of 8? Upper bound -1, simple, which is 4. But if what will happen if 8 is not there? Suppose in this case 6 is not present. Now what will be the lower bound? Lower bound is greater than or equal to 6, still 8. But we do not need to find this. This is not our answer. We have to return -1 if it is not there in our array. And upper bound, see, upper bound is also 8. It will return 3, 3, which is wrong. We want -1, -1. So if lower bound exists but it is not equal to nums of lower bound is not equal to target, what we will return? We will return minus 1, minus 1 comma minus 1. Simply, this is one edge case. And suppose we were finding 9. 9 is also not there. Oh, okay. Suppose we were finding 11. Now what will be written? If we will find 11, suppose we will find 11. Let's erase this. What happened if target was 11? 11. So lower bound will be, it will return length of this array, which is 6, and upper bound will also return 6. It will return 6, 6. But this is wrong answer. We have to return minus 1, minus 1. So in this case also, when lower bound is equal to size of a, then we have to return minus 1, minus 1, because it is not present in the array vector. So these are the two edge cases. Now we have seen the lower bound and upper bound code. We can implement simply like this. We can write STL also. What was the STL? Simply let's make the first pointer to minus 1, last to minus 1, and simply lower bound was lower bound underscore underscore. Here it will be nums dot begin comma nums dot end comma target. It will return iterator for index. We have to subtract it with nums dot begin. Okay, this was the lower bound. Suppose if lower bound equals to n, or lower bound nums of lower bound not equal to target, then we should return minus 1, minus 1. Simply. Now I've found upper bound. Find upper bound. Upper bound is similarly same syntax. Now answer is simply LB and UB minus 1. Okay, this is the simple code. You can use direct STL of C++. Now if you don't want to use STL, we have to apply a binary search solution. What we can do? What we can do is, I will show you what we can do. Suppose first is minus 1. Suppose first of all we find the first occurrence. For the first occurrence, what we'll do? Initialize first with minus 1. Okay. Then for the first occurrence, what we'll do? Simply binary search. Keep a low pointer, high pointer. What is the mid? 0. Actually, wait a minute. 0, 1, 2, 3, 4, 5. What is the mid? Mid is 2. Mid is here. Now is, we will find, and target is 8. Is 7 equal to 8? No. Is 7 less than 8? Yes. So we are not using this. This is of no use. We will eliminate the left half and we will update our load to here. Now check what is the mid. 3 plus 5 divided by 2 is 4. Mid is here. Okay. Now our mid is here. Okay, mid is here. What we have to do now? So actually mid is writing is not that good. Low is here, mid is here, high is here. Okay, is 8 equal to 8? Yes, we will update the first two 4. But is it the first occurrence? No. For first occurrence we should move to left, because on the right it will be last occurrence, or elements would be greater. On the right elements would be greater than equal to, so we will move to left till we will get till when we will move to left till we get equal to the target. So first occurrence will be available only in the left, not on the right. It can't be possible. That's why let's move the low pointer, move the high pointer to, earlier it was here, now move the high pointer to mid minus 1. See, now low is here, high is here, also mid is also here. Okay, now check if 8 equals to 8. Yes, now first will be updated to 3. Now again check, again move the high pointer to left, mid minus 1. Now high is less than L, so it will break the condition and move out of the loop. Suppose 8 was present here. Now what is the what is for last? For last, what we have to do? For last, initial will be last. We will write another function for last. It was for first occurrence. For last occurrence, we will write another. See, low, high. What is the mid? Mid is 2. Mid is 2. Is 7 equal to 8? No. Left half is of no use. Update the low pointer to mid plus 1. Now check mid. Mid is 4. 8 equal to, yes. Update the last pointer to 4. But is it the last pointer? We are not sure. We have to check where the last pointer will occur. It will be available on the right. So we will move our left to mid plus 1. Now let's check the mid. Mid is here. Is 10 equal to 8? No. So we will eliminate the right half. It is greater than 8. We will eliminate the right half and we will move over high to mid minus 1. Low is here, mid is here, high is here, mid and high is here. Low was here. High will to mid minus 1 because mid was here earlier. But this is wrong. This is wrong. This breaks the while loop, and our last pointer is this only. And first is this. So we will return them as 3, 4, and this will be the answer. Let's code it. Let's code the solution. I hope you understood. So make a function for first occurrence. We'll pass same things, same parameters. Let's pass the same parameters. Now let's take a low pointer, which is 0, a high pointer, which is nums dot size minus 1, and the first index. Initialize it with minus 1. Let's take a while loop. Low is less than or equal to high, and calculate the mid. Low plus high minus low. By 2. If nums of mid equal to target, if nums of equal to target, we have to update the first pointer, first index to mid. Also, we are not sure that it is the first occurrence, so we move to left. So update the high pointer to mid minus 1. else if suppose nums of mid is less than target, so we'll update the low pointer to mid plus 1. Else we'll update the high pointer to mid minus 1 because right half is greater than mid is greater than the target. So we will not find the right half, we will find the left half. Okay, it is nice. I think we return the first index first. Similarly, we will write for right index last occurrence. Similar code. Let's write for right index right occurrence last occurrence, and yeah, only last. Also, we have to update one thing more. We are not sure that it will find on the edge flattened index or not, so we will move over. We'll search in the right part. So low equals to mid plus 1. Yes. Let's call int first equals to first occurrence nums comma target. Suppose if first occurrence is minus 1, then there is no use of last occurrence. It will also be minus 1. It will reduce your time because now it is big of log 2n. But if it is not there, it is of no use. When first index is also not there, first occurrence is not there. So why last occurrence will be there? That's why we will save one big of log n. It will save our time complexity too much. Return a vector of first comma last. Occurrence spelling is right, I think. Okay, let's run this question. Let's submit it. Now see next question. What will be the, now we have to find the number of occurrences of the target. See, target is 2. What is the count of 2? 4. We have to do it big of log n. We can do by linear search easily, but because it is sorted and we have to search, we will use binary search. So 2 occurs 4 times. So how can you find? We have just now seen the first and the last position of an element. Suppose this is first and last position. You are seeing. We'll just subtract it and plus 1. I will show you how. Suppose I will take the screenshot. Just paste it. Yeah. 0, 1, 2, 3, 4, 5, 6. Okay. So first occurrence will be 2, last occurrence will be 5 from the last code, and answer will be 5 minus 2 plus 1 equals to 4. See, this is the answer. So you just have to do this minus this minus this plus 1. This will be the answer. But what if first and last is minus 1? Then you have to return 0. Then simply you have to return 0. If first equals to minus 1, then you have to return 0. Let's code this. Simply code this. first equals to, I will copy this also. Yeah, let's write array here. Let's write array here. We will return 0, simply 0. Now we will return last minus first plus 1. Yeah, compile and run, and it should run. It should submit also. Yes, it got submitted, and boom, we have solved our question. We will meet in the next video. Till then, goodbye.